Okay, fine. So I just want to welcome everyone to this training. Thank you all for your willingness to participate. Thank you for your investments. Thank you for having the faith and trust that we can deliver this training. R is a statistical program, which, okay, someone else joining, thank you, which is gradually taking over the world in terms of research and statistics. Most people are migrating from other platforms to R, from SAS, from Stata, from SPSS to R. And the reason being that R, number one, R is free and open source. There are some other statistical software programs that you have to pay some good money for to get installed and use. But R is free and open source, so that's a very, very good thing. Number two is that R is reproducible. So if I do an analysis in R and I have all the codes that I've written for that analysis, some other person in another part of the world can use that same code and produce the same results that I've produced. That's a very, very good thing about R, which some other platforms do not have. So if I write a code here and I have a partner in for example, if Momikesh was collaborating with me, she's in the Netherlands, I could just send her my codes and she could run my codes on the same data and she will produce exactly the same results. So that's one advantage that R has. And then R is also repeatable in that if you have an ongoing project, maybe it's a yearly collection of data, and you collect data in 2020, and you run the R package on it. If you have additional data into that data set, probably in 2021 or 2022, you don't need to start all over again to analyze that data set. All you need to do is take the additional data, put into the data set, and run the same R code that you did in 2020, and it will produce an updated version of the analysis for you. So those are some very unique things about R, which makes R very, very outstanding in the world of research. So those are unique things about R. Sorry, some people are joining. I want to make sure. Some people are joining, but it's finding difficult to admit them into. Okay, so like we started in R, first of all, I just want us to get comfortable with R. Even though R is a house of codes, it's not that difficult like some people make it sound. R can be very, very easy to learn if you dedicate time to it. So I want us to feel very comfortable with the R learning environment. So I'm happy, I'm sure all of us here have installed the R studio on our systems. So right now I'm going to be sharing my screen so that we can begin to look at what R is and our environment looks like and how we can move forward from there. So I'm going to share my screen right now. Please, like I said, if there are any questions, put them on the chat. However, if you feel they need to be answered before we move on, then you can unmute your sound and ask the questions. Okay. So can we all see my screen? Either just indicate by your hand or say something. Can you all see my screen? Okay, fine, good. Mommy Cash, can you see my screen? Hello, can you see my screen, Mommy Cash?
I gave you a thumbs up.
Oh, fine, fine. Thank you very much. Okay, so this is the R environment. Usually there are 4 quadrants in R, like I wrote in that document I sent over. So this first quadrant here in the top left corner is what we call the source quadrant. And in this quadrant, that's where you write your codes, all the codes that you write for your data analysis, your data cleaning, data manipulation, data visualization, everything, you write it in the source page or the source window or the source quadrant. That's basically what this window is for. This window also shows us when we import data sets and open them up, it also shows on this window. For example, you can see this is a small data set that I just created and I imported. So those are the 2 things that show on the source quadrant. So it's a place where you write all your codes, and then it's also a place where you can view your data set. Okay, second, we go to the second one. The second one is called the console. So the console is just where R documents every code that you write and gives you the results of the codes that you have written. So that's what the console does. So if I type, for example, let me. Okay, for example, I have already a data set I have imported into R, which is this one here. And I want to find out, okay, this data set has name, age, sex, weight, height, and state for about 19 different people. And I want to find out what is the average or the mean age of this participant here. So what I need to do is just type in the code for that, which is mean. I'm going to highlight it so you see what I'm talking about. So you just type in mean in brackets and put the name of the variable, which is the age, and then you click on Control Enter. Once you click on that, you can see down in the console page, it has produced the mean of the age that we just typed in the source page. Did we all see that? Okay. Okay, fine. So that's what this console part is. It just gives us the results of the code that we have typed in, and then it also documents what code we have written. So all the codes that you will type on the source page translate itself into the console and then produces the result of what you have typed. Okay, let's go ahead. Now, the third part is this part we call the environment. The environment stores basically objects. We call them objects in R. Objects are like maybe your data sets, tables, whatever things that you work in R are being stored in this environment page. For example, the data set I'm working on, which I call voters, is here, and it's stored. It just gives me a summary that it has 19 observations of 6 variables. So we can see that's where R stores its objects here. And then the fourth quadrant has a couple of things in it. First of all, it has files. The files just document every document that you have concerning each project that you're doing. For example, before we started this, I created a project called R training. So R stores that in these files, And then the data set, which I also created, is also here, this voters Excel sheet. And then the script that I'm writing, this code that we're going to be writing, is contained in a script called voters. So every document that you use in any particular project that you create, R stores them very neatly inside this tab called files. Let's go to the next one called plots. So plots is the place that gives us a visualization of whatever plot or graph that we put in a code in R. If we want to produce a bar chart, once we type the code in the source page and we click enter, the graph or whatever it is that we have plotted is shown in the plots. So this is an example of a box plot, which R has shown in this place. So plots just shows us the different visualizations of analysis that R can give us. Then let's move to the next one, which is packages. Packages, R works with packages, and packages is a very, very beautiful. Packages is a very, very beautiful thing in R. Packages are like bundles of functions that R has to increase its vocabulary. So in R, when you install a package consists of a series of functions that you use to give commands in R. So those are what packages are. And you can see R has thousands and thousands of packages that it works with. And those are them all in this place. So we'll get to learn more about packages as we move ahead in this training. The next tab is help. So help in R is a very, very good thing in that whatever thing you do not understand in R has a help for it that can explain to you what that thing is and gives you examples of how you can utilize it. And how do you get to help in R? If I come back to this console, this source page, and maybe I don't know about mean, the function mean in R, and want to know what it is and how R uses the function mean in R, what I need to do is to type the question mark. Let me just give space. I type a question mark and I write that function mean, and then I click Control Enter. And one beautiful thing in R again is once you're typing something, R can give you a list of things it thinks that you're typing, that you want to type. And then you can actually click which of them that you want. For example, as I typed this, R has produced a list of boxes to predict what I intend to type. And the one I wanted to type is this first one, which is the question mark on main. So I can just click it. And then I click Control Enter. Once I do that, it immediately go. If you look at this last quadrant, the down right on, you can see it has produced what mean is. It gives you a description of mean. It gives you a usage of mean, and it goes ahead, gives you the arguments that you can use with mean and all that and all that. And at the end, it also gives you examples of how you can use that function. So that's a very good thing that R does. So whatever thing it is in R, whatever, just type a question mark and type what it is, and then click Control Enter. Before I go ahead, I have assumed that all of us are using Windows. Is that a correct assumption? I know maybe some people are using Mac computers or something. All of us using Windows. Prof, are you using Windows? Yes. Gabe, you're using the Windows? Yes. Mamikesh, are you using Windows? Okay, thank you. Yeah, Dr. Nura is joining us. Let me just welcome him. Hello, Dr. Nura. Can you hear me?
Yeah, I can hear you.
Okay,
yes.
Awesome. That's excellent. Dr. Nura is joining us from Egypt. He's Dr. Nura, let me just give a brief introduction because we all introduce ourselves. Can you just introduce yourself briefly?
So, I'm Dr. Nuruddin, working at Orthopedic Hospital, Wamako in Sokoto. I'm a medical doctor working there. So, that is all.
Okay, Dr. Nura is actually the CMD in Orthopedic Hospital in Wamako, Sokoto, but currently he's in Egypt for a training. Dr. Nura, you're welcome. We started a couple of minutes ago, so I'm sure you'll catch up. Yeah. Okay, so fine. So we've been able to define these 4 quadrants and most of their functions. Okay, so I just want us to, okay, like I said, R works with basically functions and objects. Those are the 2 main things R works with. A function is like the command you give to R, and then the object is like what you give that command on. For example, if I use the same mean age I used earlier, mean is a function. So it's a command that you give in R. You want to know the average of a particular set of observations. So you give a command, and that command is called a function in R. And then what you actually work on are called objects. So the data set can be an object, a variable can be an object. So for example, age, if I go to this data set, so this entire data set here can be an object in R. Then each of the variables, for example, age, sex, weight, can also be an object in R. So R is just a combination of functions and objects. Mean is a function, median is a function, plot is a function. So any command that you give is called a function. And then what you're giving that command to is called the object. Okay, so let's move ahead. Okay, so now I just want us to familiarize, to know that R is easy, it's not difficult. So I have created, before we started, I have created a data set of 19 people. 19 of them, I have collected their names, their age, their sex, their weight, their height, and what state they are from. So I have 6 variables that I'm working on. Okay, just to reiterate again, data sets are like a table that contains information that we want to work on. And there's what we call tidy data in R. It is good that from now on, when you want to do your data set, that you make it in a tidy form. A tidy data is easier for analytic softwares to work with tidy data than to work with data that are not tidy. When I say tidy data consists of 3 components. Number 1, all variables in a tidy data are in columns. For example, we have this first column is the column of names. The second column is a column of ages, then sex, then weight. So every variable has a column. So the name variable has its column, age variable has its column, sex, weight, etc., etc. So that's one of the components of a tidy data. The second component of the tidy data is every observation has a row. So there are 19 observations here, 19 units of observations here. If you look at it, that's from 1 to 19. And each observation has a row. an observation it's like a unit. For example, Aminu is one observation. Aminu has an age, has a sex, has weight, has height, and has a state. So this entire row of Aminu is the observation. So every variable has a column, every observation has a row. The third component of a tidy data is that every value has a cell. Now, each of these things within this data set is called a value. For example, 19, this age 19 here is a value. This weight of 48 is a value. The state of Imo is a value. So every value has a cell. So those are the three components of a tidy data. I'll just go through them again. Every variable has a column. Every observation has a row. Every value has a cell. So if your data set is configured like that with these three things in mind, that is called a tidy data in R. And it is very, very important that going forward, all our data is arranged in this format, because once it's in this format, it helps your analysis to go very smoothly, and you don't have to do so much data cleaning and manipulation during your analysis. Okay, so having said that, let's go back to our script. So we're going to be working on this data set here, which I have already imported in R. I will show us how to import, but let's just look at how to work on this. Okay, so I want to find out what the mean age of this data set is. Like I said, you just type the function and the object. The mean is the function, and you open up a bracket and you put in the variable that you want to work on, which is age. And then since all of us are working on Windows, you click Control Enter, and it gives you, if you look at the console, it gives you the mean age and tells us the mean age is 40.78. Okay, so we can do for the median in the same way. Let's look for the median of the height, for example. And then we click Control Enter. It tells us that the median of the height is 153. Can we all see? Okay, so let's assume we want to make a table of the sex. We click on table, open up a bracket, and then you type sex in it. And then you click on Control Enter. So you can see it has given us a summary table of sex. It has shown us that there are 9 females and 10 males. Can we see that in the console? Okay. So let's assume we want to do a plot of what the age looks like. The same thing, we write plot, open up a bracket and write the variable, which is the age, close the bracket, and then we type Control Enter. Now, if you look at the bottom quadrant, the bottom right quadrant, it has shown us a plot. This is like a line plot of what the age variable looks like. Can we all see that? Okay, fine. So that's just how R works. You just type in the command, which is the function. You open up the bracket and you put in the object which you want to work on, close the bracket, and you click Control Enter. So that's basically what R is. Let's assume I want to look at a relationship between age and height. I can do plot. bracket open, age, comparing it to height. So we do Control Enter again. So this plot here has just given us a plot between age and height. Can we see that? So I just wanted to look at the relationship between age and height, and this plot here has given, it has age on the y-axis and has height on the x-axis, and then it has given us a plot on what the relationship between age and height is. Now, if we look closely at this plot, we can see that there is some kind of correlation between age and height. As age is increasing, height is also increasing. If we just take it, look, but all those would understand, we'll look at later. I just want us to just appreciate how to give commands in R and how to use functions and objects in R. Next, let's assume I want to do what's it called now? Statistical analysis on this age and height relationship to see if there is a correlation. I can just do a correlation test. Like I said, once you start typing the function, R gives you a list of things that it thinks that you want to type. It tries to predict you. And that's a very wonderful thing because you can just look at this and select what you want from that list. For example, I want to this second one, that's what I've selected. And then I click on age and height to look at the correlation. And then I click Control Enter. Now you can see in the console, it has given us a correlation coefficient. It has even given us a p-value. You can see the p-value here. I'm highlighting it. The p-value between age and height, it has given us a p-value of 0.4, which if we had used an alpha level of 0.05, we know this is not statistically significant. So you can see it's working in R is just very, very easy once you understand the functions and the objects. So you can see this has given us, it says Pearson product moment correlation. It tells us what data it works on, that it worked on age and height. It tells us the degree of freedom, 17, the t-value gives us the p-value. And then it also tells us it's used a 95% confidence interval to work on. And then it also gives us a range here of the confidence interval from minus 0.3 to 0.5, which includes 0, which makes it not significant. So that's basically how we work in R. Okay, thus far, do we have any questions? Anyone has any question thus far that we need to clarify before we move on?
Though I joined late, I don't know whether it was at the time I joined that you started the lecture, though I have myself to blame for that. But so far, so good. I'm following the lecture and appreciating your explanation. So
Okay.
let's move on. Let's not waste time. No, let's move on. That is good.
Okay. Thank you very much, Dr. Nura. Okay, so next, what we're going to do is we're going to import. I'm going to open up another fresh R, and then we would import data into R, and then we can see how to work on it. Now, once you have a data set, the first thing you want to do, whether you're using R or any other statistical analytical software, is you want to explore the data. That's the first thing. That's the first step in data management. You want to explore the data. And when I say explore the data, you want to look at what are the various components that data has. You want to look at how many observations are in that data. You want to look at how many variables the data has. You want to look at what are the different types of, what do you call it now? This just skip my mind. Okay, when I remember, I'll let us know. But when you explore data, you just want to generally acclimatize yourself with that data to know what exactly the data is before you start working on it. And that's what we're going to do now. I'm going to import a data set, and then we're just going to explore the data, try to understand. It's just like having, should I say, a romance with the data, trying to understand the whole component of the data summarily before you now begin to work on specifics on that data. Okay. Okay, one thing I forgot to tell us is that R has embedded in it so many data sets that you can use and work on. So many data set examples that have been used in the past. And they are actually real data, most of them, that you can use and work on. For example, if I want to look at all the data that R has, I can just click data. And then click Control Enter. And you can see a barrage of data sets that are available in R. And you have these data sets to work. You can choose any of them and work with. You can choose any of them and work with. There are different data sets from, for example, even this, what's it called? There's this data set on in London about doctors that they did on cardiovascular disease risk and stuff. They're here. So there's just so many data sets in R that you can pick and work on. And I encourage everyone at your leisure time, just go pick up a data set and just exploit. The more you explore data, the more you begin to appreciate how data exploration really functions. Okay, so like I said, I'm going to import, or I think I have a data set here already we can work on. Okay, before we do that, I'll just show us. Okay, so like I said in the beginning, R works with packages. And packages, like I said, are like a bundle of functions that R has to expand its vocabulary. And functions, there's so many functions that R has that you can use almost any functions to do anything. But there are basic functions that if you're doing analysis, like for me, I have selected a few functions that I know are very, very important and very necessary for me to do any analysis I want to do. And that's what I'm going to show you now. If you look at this page, the source page here, you can see a couple of functions. This RIO, Rio here, scheme R, tidyverse, GT summary, R statistics, janitor, forecast, lubricate, scales. They are all packages in R that have functions in them. So I have like looked at most of the analysis I do, and I have come to realize that once I have this about, I think there are about 10 or 11 of them. Once I have these 11 packages installed in my environment, it can help me do whatever analysis I want to do. So usually what I do is before I start any analysis, I just do this. And how packages work in R is, first of all, you install the packages in R, and after installing them, then you load the packages. You first of all install the packages, and then you load the packages. That's how this works. When you install packages only once. Once you install a package in R, you don't need to install them ever again. They are there. However, when you start working on any new R environment, you have to load the packages. So that's the difference. Installation is done only once. So because I have installed this, they are already in my R. Whenever I want to work on R, I already have them installed. But to use them on this package, I have to load them into the environment so that I can start working on them. And if we look to install any package, the function to use is install.packages. This one I'm highlighting here. That is what you use to install any package in R. You type that, and then you open up the brackets, put the package you want to install on inverted commas, close the bracket, and then you click Control Enter. For example, to install this, Pacman is a package in R. I just do that and then I install it. Now the time for this session is drawing to a close, so I'm going to end this meeting, and then I will restart and invite us all over again so that we can start up the next session for installation. Is that okay? Okay, thank you very much.